Hi all and welcome to this video, which is going to cover the class from Friday the 13th of September, so it's class 10. So I'm going to run through all the slides that we did in class, run through all the examples. The first thing I'm going to do is correct homework. So I'm going to go through the solutions very quickly. If I move in too quickly, pause the video and you'll be able to work through the solution. So the first question, question 5 here, the line segment joining 4, -1 and -4, what is the diameter of a circle? Find the equation of this circle. So the method that they've used here in the solution is finding the midpoint, which is 0, 0, and then working out the distance from 0, 0 to one of the points on the circle, which gives us the radius. Now, an alternative method here would have been to just work with the distance between the 2 points and divide it by 2. Or you might have actually said, well, we're only dealing with circles with center 0, 0 in this exercise, so you assume the center was 0, 0. I would just be careful about doing that because obviously when we're in an exam situation, we won't be able to make any such assumptions. So question 6, it was asking us to write down the radius of each of these circles. So part I, so square root of 9 is 3, that should be relatively okay. Square root of 1 is 1, and square root of 27 can be simplified down to 3 root 3. So this question here, part 4, just be very careful. Remember that our formula for the circle is x squared plus y squared equals r squared. And similarly, when we talked about the equation of a line, y equals mx plus c, the y had to be on its own. And, well, when I say on its own, I mean a coefficient of 1. And the same thing applies here. So this is a 1x squared and a 1y squared. Because we have a 4 here and here, the first thing we're going to have to do is divide across by 4 and then. So our final answer here, when we square root 25 over 4, we get 5 over 2. The same thing needs to happen here with part 5. We have to divide both sides by 9 and we end up with 2 over 3 for our radius, and in this case both sides by 16, 7 over 4. So question 7 has the line 2x plus y minus 5 equals 0 is a tangent to the circle with center 0, 0. Find the length of the radius of the circle and write down the equation of the circle. So this is very like example 2, which we did yesterday in class 9, so that was Thursday. And when we did that example, we didn't have the diagram. We had to do a sketch, but they've very kindly given us the diagram in this question to make it a little bit easier. So one of the things that we said, and we'll talk about it a little more as we move through the video, is that the radius, which is here, will always meet the tangent at a right angle when they're at the same point. So what we're dealing with here is from page 19, the distance formula. So it's the perpendicular distance formula from the top of page 19 that we covered in the line. And we're finding the distance from 0, 0 to that line, which will work out at root 5. The workings are there. And we get our equation of our circle here, which is x squared plus y squared equals 5. And the last question was question 10. So find the equation of the circle S with center 0, 0 and radius 2 root 5. Okay, so that's the first part. And then it says T is the line x minus 2y plus 10 equals 0. By finding the distance from the center of S to the line T, determine whether T is a tangent to S. So working with center 0, 0, radius 2 root 5, subbed into our equation, we get our final equation as x squared plus y squared equals 20. We then want to look at the line. Now, it very kindly gave us a little yellow box here, which says a line is a tangent to a circle if the perpendicular distance from the center of the circle to the line is equal to the radius length. And reading that, you might go, yeah, okay, that makes a lot of sense. But remember, would you think of doing that in an exam if this kind of question came up? So sometimes when we see it, we're like, yeah, that's logical to do that, but would we think to do it? So what we're going to do is work from the center 0, 0 out to that line, and we work out that it is a distance 2 root 5, which is the radius. If you think logically, if that perpendicular distance was further away, the line will be outside the circle. And if the perpendicular distance was shorter, it will be inside the circle, and that will become a chord. So make sure to answer the question and here yes or yes, hence T is a tangent. So this is for putting into your copies. We're talking about coordinate geometry of the circle. We're in book 4. It's chapter 4, so we're in Text and Test book 4, it's the originals. And we're 13th September 2019, class 10. So we're going to look at some of these words straight away. So chord, diameter, radius, tangent. So these are some of the things that have come up over the last few days while we're working with the line and more specifically the circle. So we're going to look at where they sit. So if you need to pause the video to take this down, go ahead. So look at this circle here. We have a lot going on. We have some things that we know, and some things that you should know are the diameter, which is a line that goes from one end of the circle to the other, but it goes through the center. We also have the radius, which is half the diameter, or it goes from the center of the circle out to the edge of the circle. One of the ones we've talked about in the last few days has been a chord. So a chord is a line that cuts the circle. And remember that the diameter is actually a special chord that goes through the center. We then have an arc, and this is something you probably came across when you were doing your constructions at junior cert. So arc is like a part of the outside of the circle, so it's part of the circumference. We then have tangent here. So our tangent AB, it touches the circle only once. And the last thing that's in this diagram is segment, which is up here, which is a piece of the circle. And it's a very specific piece of the circle. Look at the way that it's cut. We also have a sector. So a sector of the circle, which we'll look at in a lot more detail when we're doing our trigonometry. And that will be the sector. So our sector would look like a slice of pizza. The segment is what is cut off using a chord. So now we're going to go through some of the circle theorems. You don't need to write these out if you're watching this instead of being in class. There is actually a little printout that's about half an A4 page for you to stick in. So at this point you should have had your keywords, you should have had that circle diagram that we had on the last slide, and then this circle theorem sheet will be stuck in. So if you're taking down notes, leave a space. So there are two main theorems in a corollary. So the first theorem is theorem 20, which is about tangents, and it says each tangent is perpendicular to the radius that goes to the point of contact. So that's saying a tangent and a radius are perpendicular when at the same point, and you can clearly see it over here on the right. It then has the second part of the theorem, which states if P lies on the circle S, and the line L is perpendicular to the radius at P, then L must be a tangent. Okay, so we can work this both ways. If I know it's a tangent, I know it's perpendicular. If I know it's perpendicular and touches the circle, it must be a tangent. So the corollary of that theorem, theorem 20, is if two circles intersect at one point only, then the two centers and the point of contact are collinear. So we would have looked at collinear quite recently when we did the area of a triangle. Remember, collinear means lie on the same line. So here's my point of contact. There's my center 1. There's my center 2. Similarly here, center of the big circle, center of the small circle, center of the point of contact. So we talk about these circles as touching externally. So if you look at the diagram, hopefully that makes sense why that's called externally, because they're touching outside. And then this one is called touching internally. And we'll do a lot more with this. And actually that's the basis for quite a lot of our exam questions. So this idea that the circles touch externally and internally. And we'll do a little bit more about that when we come to that section. So the last theorem is theorem 21, and this is also a really, really important little theorem that comes up in quite a number of circle questions, and we utilize it. And it basically says the perpendicular from the center of a circle to a chord bisects the chord. So remember that bisects means to cut in two equal pieces. And you can see here that they've done our double lines to show that the perpendicular from the center, so here's my center point, and the line comes through the chord and it is perpendicular, it will bisect the chord. And then the second part is this: the perpendicular bisector of a chord must pass through the center of the circle. So if I know that line cuts the chord, then I also know that line must go through the center. And if it continues to the other side of the circle, it will be a diameter. So that is ready to be stuck into your copies. So next we're going to do a little bit of work with circles that don't have a center 0, 0 and instead have the center HK. So like we did on Thursday with the circles with center 0, 0, we're going to say let's work out the radius or of a circle with center HK and that contains the point XY. So let's take a circle with center Q, which is HK, so you can see on the diagram, and radius length R. Let P, XY, be the coordinates of any point on the circle. So to calculate the distance from Q to P, we use the distance formula, which is on page 18, and it looks something like this: x minus h squared plus y minus k squared, all under a square root. But QP is actually the radius, or, and don't like the square root, so we're going to square both sides and we end up with this little formula here. And that formula is the equation of a circle with center HK and radius of length R. Okay, so make sure that this is taken down in your copies. Again, if you need to pause the video, do so here. So that formula that we just derived is the equation of the circle, and it appears on page 19 of your log tables, and it says given center HK and radius R, the equation of a circle is x minus h squared plus y minus k squared equals R squared. So we're going to have page 19 open in front of us as we're working through the next set of examples. So just to help, I've put that equation of the circle up on top here. So find the equation of the circle with center 3, minus 1 and radius 4. So just like normal, we're going to label. So my center is HK, my radius is R. I'm then going to write my formula, x minus h squared plus y minus k squared equals R squared. So we have x minus 3 squared plus y minus 1 squared equals 4 squared. Clean this up. X minus 3 squared plus y plus 1 squared equals 16. Now, this is absolutely fine given the section that we're in. But as we move forward, there will be a requirement to multiply out and have our equation of the circle in a different form. So just to practice a little bit of algebra and just to get it in a different kind of form, what we're going to do now is we're actually going to multiply out the bracket. So if you're looking at the example in the book, or if you're working through questions and you're like, oh, the back of the book doesn't multiply it out, yeah, that's absolutely fine, but we're again always aiming towards our exams. So first thing I'm going to do is multiply out all my brackets. So I get x squared minus 6x plus 9 plus y squared plus 2y plus 1 equals 16. We generally will write it as x squared, then the y squared, then the x, then the y, then the constant. So I have 9 plus 1, which is plus 10, and I'll bring the 16 across, so minus 16. So my final answer is x squared plus y squared minus 6x plus 2y minus 6 equals 0. And that is the equation of the circle. They are only at this point in time looking for that line, but we're bringing it all the way to this line. So when we see a circle in the form x squared and a y squared and an x and a y and a constant, that we know it's actually still the equation of the circle, it is just being expanded out. So now we're going to work backwards. So find the center and radius of this circle. So the first thing I'm going to do is write my formula. So my formula is x minus h squared plus y minus k squared equals R squared. So we're going to work with each piece. So this piece here, minus h is equal to minus 3, so h is 3. In this piece, minus k equals 4, so k equals minus 4. And here, r squared equals 36. So r is equal to, really it should be the plus and minus of the square root of 36, which is plus or minus 6. However, remember, radius is length, and length can't be negative. So therefore, radius equals 6. Okay, so just be very, very careful with those square roots. When we're dealing with square roots in this section, we'll only be taking the positive answer, but don't forget that there is both a positive and negative answer. We're just saying that the negative answer is not valid here because we're talking about length. Also, when you're doing it, don't forget to bring together these as the center point. So the center is given, again I'm writing this down, h comma k, which is for us 3 comma negative 4. Now you might look at this and say, well actually I could write all that down without showing my work, and that's absolutely fine. But remember, if you write down answers without your work, it's only when things go wrong and you don't get the right answer that you really suffer badly. So just be really careful. And if you want to take that gamble, go ahead, but sometimes you might as well just show a little bit of work where it's coming from. So I'm back in my log tables now on page 19, and we're going to look at what's called the general equation of a circle. And I've moved below the last formula. Now, if you look, it says x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is it here. And actually, based on the equation 1 we just did, this is like an expanded version. So it's like if you multiply it out. Now it does have different letters because the formula above used HK and OR. Here they don't have an OR, and instead of H and K they deal with minus G and minus F for its center. So when we're given the equation in that form, we're able to work with the center, and that will be minus G minus F, and we're also able to calculate a radius. So let's take a look at an example. So just to help, I've left that piece of the log tables up the very top, and it says find the center and the radius of this circle. So the first thing I'm going to do is underneath the equation that it gave me, I'm going to write the formula for my log table. So x squared plus y squared plus 2gx plus 2fy plus c equals 0. And then I'm going to deal with each piece. So I have 2g here is equal to minus 2. Therefore, g is equal to minus 1. In this part, I have 2f equals 4. So f equals 2. And here, c equals minus 3. Oh, sorry, minus 8. So now I'm going to get my center. So my center is going to be minus g minus f. So I get minus 1, and my f is 2, which is the same as, minus 2, so I same as 1 minus 2, and that's my center. And then I'm going to calculate the radius. So the radius is the square root of g squared plus f squared minus c, which is equal to minus 1 squared plus 2 squared minus 8. Watch your signs here, because if you end up with a negative under the square root, it will error. So if you're getting error at any point, just double check your sign, and it's usually the C where the sign will go astray, because the other two, the signs aren't terribly important because we're going to square them, so they'll end up positive either way. So we end up with 1 plus 4 plus 8, which is the square root of 13, which is my radius. So now we're going to have a quick chat about points and circles. So if I have a point P and it's on the circle, the distance from O to P should match the length of the radius. So if I wanted to check where P is, I could measure O to P, and if O to P was the same as the radius, P is on the circle. The second thing could be that P could be inside the circle. So when I measure O to P, I might find that actually that distance is smaller than the radius. Therefore, P is inside the circle. And finally, if I measure and OP is longer than the radius, then P is outside the circle. So again, these three things you might be like, yeah, of course, that makes perfect sense. But just to remember, would you do that in an exam? How would you remember to do this? Take these down in your copy just as a very quick little sketch. Take down the pieces underneath. If you need to pause the video at this point to do so, and I'm going to move on to an example. So this is example 4. Now, I'm going to do two different methods here. I'm going to do method 1, which is working with what we just took down about the distances between the point on the center and the point on the circle. And then I'm going to show you a second method, which is kind of a shortcut. And some people prefer the shortcut. Some people much prefer to work through it the long way. And that both are absolutely perfect. And that's why I'm showing you both. So the first thing I'm going to do is investigate if the point P41 is inside this circle. So we're trying to figure out, is it inside? So first thing I'm going to do is I'm going to write down my formula underneath here. So x squared plus y squared 2gx plus 2fy plus c equals 0. Okay. So I'm going to work through here. My 2g is equal to -6, so g is equal to -3. Here I have 2f equals 4, so f equals 2. And here I have c equals 4. So I'm going to try to figure out the center and the radius. So I'm just like my previous example. My center is -g minus f, and that is 3, -2. My radius is then square root of g squared plus f squared minus c. I'm filling that in. Square root of -3 squared plus 2 squared minus 4, which is equal to square root 9 plus 4 minus 4, which is the square root of 9, which is 3. So I now know the center is 3 minus 2. So that's my point O that we were talking about in the previous pictures where there was 3 circles, and we're going to measure O to P. 1. So I'm going to label it x1, y1, x2, y2. I'm going to measure O to P using my formula on page 18. So this is the distance or length formula. So x2 minus x1 squared plus y2 minus y1 squared. So that is square root of 4 minus 3 squared plus 1 minus 2 squared, which is 1 plus 3 squared, so 1 plus 9, which is the square root of 10. So does P lie inside the circle? So we have the distance from O to P is root 10, and the radius is 3. So I'm just going to clear some space to finish off this question. So we just worked out OP, and we want to compare it to OR. So OP was root 10, OR was 3. If you struggle to compare, you can turn it into so you can turn root 10 into a decimal, but actually what I would do is I would say, well, this is actually the square root of 9, so this must be bigger. So we've just worked out that OP is greater than OR, so let's sketch what that means for us. So there's O. OP is greater than OR, so P is out here. So this is OP. So my radius is just this piece here. So there's my OR. So because it's longer, it sits outside. So we would say no, P sits outside the circle. So outside the circle. So using our logic. Okay, so I'm going to show you a second method here. And just to give you a little bit of background about this second method. Remember that when we have the equation of a circle, we were able to derive it by finding the distance between the center of the circle and the outside, so a point on the circle. So because we derive it from that, it kind of has like a distance formula built into it. So what we can do as like a shortcut, and I say shortcut, but actually sometimes people are like, oh, well, it's more hassle than it's worth because of what you need to remember. That's fair enough. But the shortcut is we sub in the point to the circle. So I'm going to sub the point P into the equation of the circle. So I get 4 squared plus 1 squared minus 6, 4 plus 4, 1 plus 4, and that should all equal 0. So I get 16 plus 1 minus 24 plus 4 plus 4 equals 0. And I end up with 1 equals 0. Now this is obviously false. But the fact that we discovered that this was false actually tells us a huge amount about that point P. And what I would ask is think back to when we sub a circle or when we sub a point into the equation of a line. It's to check if the point is on the line. So if I sub in a point and it works in the equation, so as in the equation is still balanced, then that point is on the line. If it doesn't work, then it's not on the line. Now, the exact same thing happens for a circle. So if I subbed in the point P for 1 and I got 0 equals 0, then that point would be on the line. So I'm going to give you some scenarios here. So scenario 1 would be if we got 0 equals 0. Then the point is on the circle. So there's 2 more scenarios that can happen. So the first scenario is the one like we got, that the left hand side is positive. And I'll explain that in a little more now, 1 second. So the left hand side ends up being positive, and the third scenario is the left hand side actually ends up being negative. So what we can actually tell, because this side here, so my left hand side, because that, and I'm going to go over in reds, is bigger than 0, we know that it's outside the line. Now, it's hard to remember this less than, greater than stuff. So actually, if you remember positive, because the right hand side will always be 0 because we're dealing with an equation. So look at that right hand side. We're bringing it all the way down. It'll always be equal to 0 because it's the equation of the circle. So we want the left hand side bigger than 0 or less than 0. So a much easier way to think about that is the left hand side being positive or negative. So if the left hand side is positive, then the point is outside the circle. And why it's outside the circle, so outside, is because effectively what we've done is we've subbed into the equation, which is like the distance formula, because that's where it was derived from, and that distance was bigger than the 0. So effectively we worked out that that point was further away. So the last thing is if the left hand side is negative, then the point is inside the circle. Now, that should be the same answer we get working the longer method, which it is. So both methods are absolutely perfect to use. Sometimes this is a nice quick little method, but yes, it has a huge amount of things to remember at the end. So just, I suppose, make a decision which way works best for you. I would finish this off. So therefore, P is not inside it is outside. And this thing here is like a little information box. So do you need to write this on every question? Of course not. This is just how to figure out what the answer is. Okay, so that's it. Thank you so much for watching it. Thank you so much for taking down the notes and allowing us to carry on despite getting a little bit of disruption today. If you have any questions on anything that was covered in this video, I'm happy to go through it when I see you next, which is Friday the 20th of September 2019. Feel free in the meantime to message me on Teams or email me with any questions if you think they can be quite easily solved. Otherwise, enjoy your few days off, and I will see you next week.